Hi students, today we are going to derive an expression to determine the internal resistance of a cell using potentiometer. Now already you must have derived an expression for the internal resistance of a cell using voltmeter. Okay? Now this is using a potentiometer. Now you can see here CD is the potentiometer wire. The end C is connected to a battery and in series with a key, plug key K1. The other end of which is connected to the point D. So the circuit above the portion CD is called the primary circuit. And below the portion CD there is another cell of EMF E and its internal resistance is a small r. This small r is the internal resistance of the cell we are going to determine. And there is another external resistance connected here in series with another plug key K2. Now there is a galvanometer, high resistance and a jockey connected in series. So the circuit below CD is called the secondary circuit. Now in the examination, it is better if you just make a list of the components in each circuit like this. Primary circuit, Vt is the battery, K1 is the plug key, CD is the potentiometer wire. Similarly, the secondary circuit, E or epsilon is the EMF of the cell, small r is the internal resistance of the cell, K2 is the plug key, G is the galvanometer, high resistance HR, J is the jockey. Now, after drawing the circuit, how to derive? Now, always you prepare in 2 steps. Prepare this topic under 2 steps. Now, what is the step 1? In the first step, this key K2 is opened. Okay. So K2 is kept opened, only K1 is closed. So what happens now? The battery is switched on and a current is going to flow through the potentiometer wire. Okay. Now when this K2 is opened, no current is going to flow through the external resistance R. So you can keep your hand like this and cover it. The circuit, only this much part of the circuit, the current is going to flow. So now when the jockey is moved between C and D, at one position of the jockey, the current in the galvanometer will be equal to 0. That is called null deflection. And the balancing length L has to be determined. So K1 is closed and K2 is kept opened. Now current I flows through the potentiometer. Balancing length L1 is noted. So the EMF of the cell epsilon is proportional to the balancing length L1. This is the first step. Okay, E is proportional to L1 or epsilon is proportional to L1. So this is the first step. Now in step 2, the second key K2 is also closed. Okay, the second cell K2 will also be closed like this. Keep a dot. It will be closed. Now, this cell is sending some current, is it not? So, through this external resistance also the current is going to flow now. So, a potential difference or a potential drop will appear across the resistor. Now, in the step 2, K2 is closed, R is included. The resistance R may be 10 ohm, 20 ohm like that, some low value of resistance is included. Now, when current flows through this path, the total resistance in the circuit will be capital R plus small r, where small r is the internal resistance of the circuit. Okay? So, the total resistance will be capital R plus small r, and hence the current through the circuit I is equal to EMF divided by the total resistance. So, E by R plus R. Now, what will be the potential difference across this resistor? This current into resistance. So the potential difference across the resistor R, V is equal to what? The product of I into R. For I, we can substitute the equation 2. So what is V equal to now? E by R plus R multiplied by resistance R. This is equation 3. Okay. Now this potential difference V is proportional to the balancing length L2. Now the new balancing length, earlier at L1 distance the null deflection was noted. Now the internal resistance is also included in the circuit, so the balancing length is going to change. So now the balancing length L2 is noted, and this potential difference is proportional to L2. Substituting this for V, E R by R plus R is proportional to L2 will be equation 4. These are two equations, namely that is 1 and 4 are very important for us. So according to the first step now, E is proportional to L1. According to the fourth equation, E into R by R plus R is proportional to L2. Now I am going to divide the first equation by the fourth equation. So left hand side is E divided by ER by R plus R. And the right hand side is L1 divided by L2. Okay. Now this E gets cancelled, and the denominator R plus R is shifted up, so that R plus R divided by capital R is equal to L1 by L2, and R by R is 1. So 1 plus small r by capital R is equal to L1 by L2. Now we need small r, is it not? So this 1 is shifted to the right side. R by small r is small r by capital R is equal to L1 by L2 minus 1. Taking LCM, it is L1 minus L2 by L2. Okay. Therefore, small r is equal to this capital R multiplied by L1 minus L2 by L2. So we are measuring L1 and L2. Known values are constants, and we are including the external resistance R like 10 ohm, 20 ohm, which is also a constant. Therefore, right hand side all are constants. If you substitute those constants, say substituting R, L1 and L2, this internal resistance can be determined. Okay, I hope you must have understood well. Fine.